This part of the Module 6 assignment will examine indicators of compromise. Some of them will be discovered through reviewing scheduled tasks, shared folders, looking into existing running services and applications, reviewing network connections, etc. To get things started, make sure that your Windows target virtual machine is turned on, as well as your Kali. Make sure you're signed in. If you're looking into recall from Kali, one of the actual backdoors that we discovered is on port 667. Okay, and 667 gave us a shell access. Okay, with this in mind, what we're doing here is we need to make sure that we have our terminal open. From terminal, we're going to execute scheduled tasks, and this will help us review different scheduled tasks. Because this particular command provides a lot of output, it's kind of hard to read. So we will go ahead and output the results into a text file on the desktop called st.txt. So what I'm doing is I'm navigating to the desktop of the user account administrator that I'm logged in with. So once this is done, it should produce a file like this. We're looking into the first entry and we're seeing the folder. This is the root. It's the very first directory. It has name backdoor2. We see that it's running, which is kind of suspicious. It's odd. So if this is running, then let's go ahead and examine what it's doing. We can go in here, and because this is a server edition, go to the server manager, make sure we select the local server, go into tools and review the scheduled tasks. We can just do the same thing from control panel. Now we click on the scheduled library and we discover that we have the task running every 1 minute. And we see that the triggers, it's enabled, and we see that it's going to this executable windows.exe. It's listening on a specific port and it's serving command.exe. Now let's go ahead and find out where this file is. Where is it? If we go in and look into C, so you see how we started with the port. We were able to find out the location of a file through a scheduled task. And I'm actually going to cheat here and type in windows.exe so I can actually find the particular file. So I find it, it exists, and I see this. The file came from another computer, and to help, it needs to be blocked. Okay, so with this file, now what we can do is we can rename it. Okay, but before we do this, I wanted to kind of demonstrate something. So we have in Kali, we're using the, let's see if we can move this up. We have an established connection, okay? So look into the dir command showing us the directory listing of the system32 directory, okay? So let's see what happens if we rename this file. So we don't delete it, we just rename it to .old. And let's see what happens to our connection. So we didn't delete the file, we just renamed it. Okay, we still have an established connection, and we're able to continue with our established connection. Now next time we go in, because the file was renamed, we may not be able to open this back door. It may not be listening for incoming connection. We cannot establish access. But because we already had established access, renaming the executable didn't do a whole lot. It allowed us to persist. It's just next time we're not going to be able to connect using the same mechanism. So even if we delete it, perhaps, let's say move it from this directory to a different directory, just C Windows, okay? So we moved it. It looks like that may be a different file that was moved. Let's go and see Windows. I'm going to look for the windows.exe, and we are going to cut it, and we're going to move it to the Windows directory. Okay, let's see if this did anything. Remove the file from where it was. Nope, because we still have an established connection. So it's not the executable. We have the channel established, and even if we remove the executable, it doesn't make a difference. Okay, so keep that in mind. We have the executable that was renamed, and we put it into the Windows directory. So I'm just renaming it, not going to do anything. So if we continue down the list, we found that this schedule task has some malicious indicators. The next thing we can do is review the network connections, network statistics. So if we go in here and we type in the netstat command, from netstat we can find out what connections are established, A and OB. Using the netstat command, you can actually get a help and the different options. We're going to show the content of all network connections that are open and have a process ID established with them. Again, you can actually output the results to a text file, so you can see what's established. Look in here. We see that we have an established connection, and the process ID is 4592. So we see that we have established 131 is the IP address for our Kali. We're finding out that this windows.exe is the name of the executable. So 4592. Okay. So what we can do from here is we can look into the task kill command to actually kill that task. Okay. So if we look into the task kill, or we can look into the task manager and see if we can find the particular executable. And then kill it that way. Task kill. We needed the process ID for that particular task. Which is 4592. 4592. So we need to specify PID 4592. And let's check our Kali. See if we can see what happened. Connection closed by foreign host. Done. So this doesn't remove it, but what we've essentially done is we terminated the connection. Okay. So something else we can do from here is we can go and review startup items. So startup items typically are reviewed through MS config, and in the startup, there's no entries. Now, trust but verify. If we go in and actually look up for the startup items of the administrator user account, let's see, app data, roaming, Microsoft, Windows, start menu, programs, startup, we see that there is a file in the startup items. If we go in and edit this file, look what it says. This is starting the different XAMPP services that we have. It's using the command line, starting FileZilla, Mercury, MySQL, Apache, but also there is a hidden present. There is another executable called ncat.exe serving another port and trying to do cmd.exe. So let's go and find out this executable and see what it looks like. So we went to C, Windows, System32. We have netcat.exe. So if we go ahead and move that file as well, put it in the same space here with the windows.exe, what we can do is we can compare the two files. Now, this particular ncat.exe doesn't necessarily tell us it's malicious. Okay, there's nothing indicative that is not. The only thing that is here that I can see is that it's not signed by Microsoft or somebody that has a legitimate signature. So what we will do is we're going to use a built-in Windows utility to be able to compare the signatures between the two files to give us an MD5, and we can use the MD5 to go to a service like VirusTotal and find out if the file is malicious. So a hash file, we need to provide the location of the file, which is Windows, and the name of the file is ncat.exe, and we need to calculate an MD5. And MD5. All right, so here's the MD5. Now the name of the other file is windows.exe.old, and we want to calculate an MD5 of the same file. Now look at this. The file hash is actually the same. So this is the same file, just renamed with a different name, windows.exe and netcat.exe. This essentially is a netcat backdoor. And let's see what tool like VirusTotal perhaps says about this file. So if you use the hash, so you grab that hash value and you paste it into VirusTotal, it tells us that some antivirus engines are detecting it as a malicious malware, right? It's malicious file, malware. 8 out of 65. Look into the community and most of the people say, oh, it's a good one, safe. Well, it depends on how we use it. NCAT could be used as part of the Nmap suite for good things like transferring files, encrypted. Now, for the purpose of our assignment, netcat is a Trojan. It's a backdoor that allowed us to gain remote access to our target. So this is how we were able to go in from one user to another. Now, other things that we can do and inspect, we can use the net use command, looking for any entries, net sessions for established network sessions. We can use the net users command for any network user accounts. So we see that we have the administrator account and this. So unless these accounts are compromised, there's nothing else like, attacker or a name that we don't recognize. The other thing we can do is we can find out any shares, net share. So in here, these are shared folders. We see that users and administrator, these three folders are shared. Okay. These folders are default shares, and we can always restrict the attack surface by changing permissions, but these three folders are going to be of interest to us, and the XAMPP one is the one that we were able to go in and take advantage of with anonymous sharing. So if we go into C, we go into XAMPP, actually we want to right click on it, go to properties, we check into the sharing, and we see that everyone has a read write. We want to remove the everyone, okay? And then we can reshare that folder. I'll take a second. And then the other thing that we wanted to look in here is the additional permissions for the XAMPP. So we see the everyone has permissions, and we don't want everyone. We want to make sure only administrators do. And we click OK, and we click close. So we can still leave the folder shared, but we don't need to provide anonymous access for someone or give anybody access to this folder, especially full permissions. So the next one is the users folder. So we come in here, we look into the sharing properties, see who is it shared with, find out everyone. Again, that is not good. And we apply. So now it's only shared with administrator. Administrator needs to provide username and password to be able to authenticate. And then we also have the users administrator folder, which was shared. Okay, we look into the permissions. We see that it's shared with everyone. We don't want that. So nobody's going to be shared with, unless we want to add, a share name. We added permissions. We can add a specific group or a user account. Click OK, apply. Great, so we removed those out of the list. So we looked through the scheduled task, we looked through comparison of the different files, looking through the startup, looking through the network connections, and also looking through file shares.